Thank you all for coming. This has been a great first annual San Francisco Climate Week. Yeah, I'm really excited. Who is this their first San Francisco Climate Week event? Hands out there, yeah? How many people have been to other events, including this one? Yeah, and who wants and is excited about this happening again next year? Yeah, I hope a lot of people are inspired to continue to participate. It's been a really great week, and I'm really proud that we have this event to round out the week and kick off Earth Day, which is tomorrow. So thanks again for everyone showing up. Today we're going to talk about climate removal, or carbon removal, carbon dioxide removal, climate removal, no. Yeah, it's been getting a lot of attention lately, and I think it's an important topic for us. It's extremely critical in the fight against climate change, and while it's not the only thing we can do, it's going to be an important thing for us to tackle on top of aggressive decarbonization. Now, it's important for us to look at carbon removal. We need to stay below 1.5 to 2 degrees warming. And, you know, what we've said is that we need to capture something like 10 to 20 billion tons of carbon. And at the moment, we're only doing around 6,000. So how are we going to get there? And this is really the topic that we really wanted to hit in this particular talk. There's been so much attention, a lot of work being done, and I'm really excited to welcome my guests today. Each of them have been dedicating their work in this space, and I'm just so honored to have them here. Our first guest is Mary Yap, and she is the co-founder and CEO of Lithos Carbon. Her background has been in geology and planetary sciences, and she worked on climate research at Yale. And for the last over 6.5 years before she was at Lithos, she was helping to scale startups. Very proud to have her here. Our next guest is Svenja Telle. She's with Base Carbon, and she's the director of origination. Base Carbon is a trusted financier of carbon credits and helping the carbon credit market. She is an analyst at PitchBook and is a doctorate fellow at the Gund Institute and is currently a climate policy advisor to the UN on carbon removal. And finally, we have Matt Atwood, co-founder and CEO of Aircapture. They're looking at DAC. He's a technologist and entrepreneur. He's been doing renewables and climate tech for the last 20 years. And for over the last decade, he's been focused on DAC systems. So please welcome these guests. I wanted to start off, I know that there are a lot of people here who are aspiring to be part of climate tech work, and you guys all have interesting backgrounds. Wanted to hear a little bit about how you got into the work and the roles that you're doing now.
Hi, everyone. Excited to be here today. Thanks for coming out on a Friday night. So how I got into climate tech, I actually dropped out of school when I was 18, taught myself to code, did software tech for 6 years. It was really exciting. I loved scaling things, figuring out how you get your first user, your 1,000th user, your millionth user. But at some point I realized if I had to work on one problem for the rest of my life, software actually wasn't going to be it. And I've always been a nature junkie. I scuba dive. I love to hike. Nature is just really it for me. My family are farmers overseas in Taiwan. And so I went back to school, decided I wanted to figure out how do you move around atoms, not just bits. And so that's why we started Lithos Carbon. So we do enhanced rock weathering, permanently capturing carbon from the atmosphere. The thing I'm excited about is the fact that we are actually bringing benefits to farmers while also permanently capturing carbon. And also there's a lot of scale in it. So we are working on scaling very fast. We figured out a way of making rocks capture carbon very quickly. And so we are trying to just chase after the climate crisis and figure out how we can tackle this problem as quickly as possible.
Great, thanks.
Thanks for everyone to come here. It's been a long week for some of us, maybe for all of us. And thanks to you for having us here on the panel. And how did I find my way into carbon/climate? Well, my family upbringing is oil and gas. My dad was a pipeline engineer for crude oil. So I think a lot of it is family karma. I always like to argue with them over dinner. And now 10, 15 years later, I'm working in the trenches of climate technology to basically reverse a lot of what has been done over the last decades. There are many, I always talk about climate tech not as a vertical in the industry, but more as a horizontal. Like whatever you do, wherever you are, there's always a seed of climate tech in every single industry. I really focus on building synergies across industries, especially hard to abate, hard to decarbonize industries, maybe also family heritage. And very excited to talk a little bit more about the challenges in the carbon market, especially from a financial perspective, and how to build safe rails in this market to scale it safely and allocate the carbon, the capital in the most efficient way.
Hi, everybody. My name is Matt. My story is I'm a chemist by background. I was doing quite a lot of work in designing new ways to make known compounds for industry, but starting with nature-based products. So synthesizing the things that we use day in and day out, but starting with starting materials that were biologically derived. And through that journey, I started probably in the early 2000s, getting really interested in renewable fuels, worked in first generation biofuels, looking at technology development, thinking about how to scale biodiesel, ethanol, things like that. And was very interested in new materials, new processes, new technologies that could have a scalable impact on carbon reduction. Started an algae technology company because at the time I thought that this was the most scalable technology I could imagine to make profitable products that we need every day while drawing down CO2. And through that process, direct air capture was sort of a new and interesting technology. I thought, well, maybe it's a technology of the future that will always be of the future because it sounds like a really hard problem to solve. But if we could figure it out, probably the most scalable technology to do carbon dioxide removal, and just kind of focused on there. And over the last 10 years have been focusing all of my efforts on what I see as the most sort of scalable technology for engineered carbon dioxide removal.
Thanks. So there has been a lot of attention put on carbon dioxide removal, or CDR. I was wondering if you could help distill a lot of the jargon or the acronyms, CDR, CCUS, MVR, all of these that people have been hearing, and try to boil it down so that people can know what to focus on and what are the really relevant basics that people should know and understand as they're thinking about carbon dioxide removal.
Yeah, happy to kick it off. I always joke that the VCM, the voluntary carbon market, is a very cryptic space. So around VCM, MRV, DAC, CDR, ICVCM, BCMI, I could go on and on. If you know all the acronyms I just mentioned, please raise your hand. Yay, I'm happy to have you here. And all the others as well, because that's exactly the point. It's a very, very secretive space in a way. Having worked at the UN, one of my old colleagues is here, maybe other ex-UN employees are here. You're used to very cryptic language, but that doesn't help to bridge the gap. I always think about how to build collaborations, how to sort of demystify the space and make the language and the capacity building across carbon markets, technologies, and corporates that are at the end of the day the buyers of the carbon credits easier. So I have another acronym, the IPCC AR6 report. Yes, thanks, I count on you. It's a very interesting indicator. It's basically the driving force in the carbon market, especially in the carbon removal space, that is motivated through carbon markets and decarbonization. It's the largest coherent report that is published by the UN, specifically the UNFCCC, the United Nations Framework Convention for Climate Change. You probably all have heard of COP, right? Paris Agreement. Well, we are getting into COP28 this year in Dubai. Never gets old. It's one year after another. And the whole goal of this is really to achieve the Paris Agreement, which is driven through science. The science comes through the IPCC report, which is a collective of scientists around the world that determine the pathway of climate change. We've all heard 1.5 degrees, we've all heard 2 degrees. In order to stay on that pathway, we see different numbers floating around. The last IPCC report says that by, I need to look because it just changed, by 2050, we need 6 gigatons annual capacity of carbon removals. Before, we've seen other numbers floating around by the World Resource Institute that mentioned 10 gigatons of annual capacity of carbon removals by 2050. The point is that the lifetime of carbon in the atmosphere is not helpful for this target or for this effort, because the capacity after 2050 up to 2100 has to go up to at least 20 gigatons a year annually capacity to remove carbon. And in my humble opinion, that's by far not enough. Those are very, very conservative numbers, which are, frankly speaking, already daunting because we are not even close.
Yeah.
Back to you.
No, I appreciate that. I think that's such a great context for what we're trying to talk about today. And I think it starts with individuals doing incredible work. And a lot of it has to do with hardware, but also around some of the financing mechanisms. And that's a lot of what we want to touch on today. So just with that context, Mary and Matt, do you want to talk about what you guys are doing with your companies?
So at Lithos Carbon, we're about a year old, but we've been doing our research for closer to a decade. So, we're not just getting started. So what we do is we permanently capture carbon from the atmosphere using the power of volcanic rocks. And that sounds a little wild, sounds a little sci-fi. So I'll give a little bit of a little science lesson on how that works. There's already a process in nature, which is what Lithos Carbon, Lithos means rock in Greek. That's what we're inspired by. There's already a process in nature that removes about 1 billion tons of CO2 from the atmosphere every year. And without this one process in nature, we actually would look a lot like Venus with greenhouse gases everywhere. So this is actually called natural silicate rock weathering. Basically what happens is when CO2 is circulating around the atmosphere up there, it combines with rainwater in the clouds to create acid rain, which we've all heard about. When acid rain hits special kinds of rocks across the world, leads to a chemical reaction that transforms that CO2 into something special called bicarbonate, the kind of stuff the seashells are made out of. That goes off into the rivers, into the surface ocean, can become the shells of like phytoplankton or corals. When those creatures die, it falls to the bottom and becomes solid rock. It's an incredibly powerful, meaningful process on Earth. What we do at Lithos Carbon is we are working on scaling that up and speeding that up by about 100 to 1,000 times. We spread a specific kind of rock dust that's crushed up. It has more surface area. It's actually a waste byproduct. So we love circular economies over here. We're actually using something that nobody else uses, but it already exists today. We bring it to farmlands where it actually improves crop yields for farmers by up to 40% in our real farms today. And at the same time, it captures carbon. We measure that very carefully with very diligent MRV. And so that's what we do. We are building a circular economy, trying to figure out how do we scale up something that already we know works in nature. How do we make it actually work much faster? And also, how do we combine this with other flywheels of growth? So coming from a consumer software background, I was like, wait, farmers, it's really, really exciting that you can actually improve something that we need. We're not, GPT-4 is wild. It's very good. We're not robots yet. We still need to eat. How do we grow crops for a growing world without increasing our emissions? Agriculture is one of those hard to decarbonize industries, right? And so killing two birds with one stone, decarbonizing agriculture, removing carbon from the atmosphere permanently. It's called enhanced silicate rock weathering. So that's what we do.
Yes, thank you. I do love that circular system piece that you guys looked at. And I think, Matt, you have a similar approach with what you're doing with Aircapture.
Yeah, I mean, what we do at Aircapture is we're a hard tech company. We build machines that captures CO2 from the air, and then we try to do something useful with the CO2. The first rule in direct air capture is you have to move a lot of air. CO2 is very dilute in the air. It's about 400 parts per million. So we need to move about 3 to 5,000 tons of air for every 1 ton of CO2 that's captured. So the name of the game there is to design highly efficient machines that can do this effectively, efficiently, with low energy cost, so that the effort of doing so doesn't emit as much CO2 as we're trying to pull out of the air. But that's only part of the story. The global economy runs on carbon. CO2 is not just in the products that we drink, the fizzy waters and the beer and the Coca-Cola, but it's also used heavily in agriculture. It's used in building materials. It's used in food packaging, in cold chains, refrigeration, the list goes on. But at a certain price of CO2 capture from the air, we could start to make other products that we use every day, like fuels, like plastics, like more building materials, like carbon negative carbon fiber to replace cement and steel in different applications. And for us, it's all about that cost curve and that learning by doing curve, to design equipment and machines that we can iterate rapidly, get the costs down, and find ways to sell the CO2 into various different markets. Sometimes food and beverage, not such a permanent application, does have a high carbon avoidance impact for other incumbent supplies of CO2, but ultimately making the future carbon products out of the air, where they're needed, when they're needed, at the locations that we can produce them today.
That's great. And I'd just love to hear if those are really great examples of some carbon removal technologies and companies. Are there any others that, or any other types of technologies that you guys would highlight, or especially Svenja, you've looked at a lot of them. Are there any other ones that you'd like to share?
Yeah, it's a curse and a blessing if you sit on the side of the table where you make financial decisions, what is investable and what isn't. I come across a lot of technologies that have a lot of potential, but really ask for synergies. They are often brilliant end solutions as a final stop for the carbon itself, but they really rely on upstream supply of the carbon through either point source capture from ethanol plants or through direct air capture. I like enhanced weathering. We come across other solutions, especially around a very beautiful rock called olivine, which you can crash into its subparts, and some of those parts are nickel and cobalt, which are minerals that are needed for the energy transition, on top of magnesium, which oxidizes with carbon and sequesters the carbon. So I'm, from a financial perspective, really curious about solutions that have other financial revenue streams other than just the carbon credit, because it's highly volatile. And that's really where I look into. I see a lot of potential in the mining sector for those mineral elements.
Any other ones that you guys want to highlight that you're excited about, or that you see some potential either with working with what you're doing, or just new ones that people are kind of doing?
Well, I think one of the more important types of kind of CDR technologies that we should be working on scaling, that has a lot of positive co-benefits, is biochar. So biochar is typically wood, lignocellulosic biomass that is processed in a certain way to lock the carbon up into 1,000, 10,000 year plus carbonaceous solid materials, which can then be land applied. And while this technology has some limitations around scale, because you have to move the biomass to where the machines are. So after a certain kind of distance away from the biomass, the biomass pyrolysis unit, you lose some of that carbon benefit. There are a lot of co-benefits of that product, which is reduced water requirement on soils, reduced nutrient requirement on soils, increased productivity of farmland, as well as the carbon reduction benefit. So I think this is a technology area that that should grow quite a bit, but we don't know how much of the solution set that is. Could be 5%, could be 10%, maybe it's a little more, but the overall carbon removal space is going to require a number of different technologies and different application areas. And I think I agree with Svenja. I think the technologies that that are the most interesting and scalable right now are the ones that have positive societal co-benefits.
Yeah. Yeah, I think one of the things that I'm very excited about is just the power of the natural carbon pump to capture carbon out of the atmosphere. How do we take that? How do we enhance that? So one company or one technology that I'm excited about is there's a group out there that's trying to use CRISPR to engineer trees that grow faster so that they sequester carbon faster. So obviously we all know about forestry, but these trees should actually capture carbon faster out of the atmosphere. And also they're trying to engineer them to grow in dilapidated like mine sites, places where you wouldn't have trees. So, you know, it's actually truly very additional. So it's called living carbon. We're very excited about the work they're doing and hopefully maybe doing some enhanced rock weathering in the lands that they're working on.
Yeah, those guys are doing great stuff. So now that we've kind of set the stage, let's get into the scaling part that we were talking about. And I'm sure all of you are probably tired of the question of how do you get this to gigaton scale, or what is it going to take to get to gigaton scale? But I'd love to know how you guys are tackling right now, scaling what you're doing, and what you think it's going to take to get you to the kind of the next level, or all of us to the next level.
I'll get started. I think one step at a time is the answer. You know, we are where we are. The cost for us pulling CO2 out of the air today is what the cost is. But for us, it's all about getting on the learning curve and driving those costs down. How to get to a gigaton is fundamentally a question of economics. At a certain price of CO2 captured from the air, we can sell CO2, we can make different products that will drive the capacity and the growth and the scaling demand there. And so our approach is to just work on the low-hanging fruit, find the niche places where our technology can save money for our customers, address the hard to decarbonize scope 3 emissions, address their scope 1 emissions, find pain points in the market where we can deliver our technology, provide the CO2 that our customers need, and use that pathway to drive our costs down. As we drive our costs down, we get faster and faster to scale. So I think at the end of the day, that's really the core driver of what it's going to take for a company like Aircapture, really any other company in the direct air capture space, to get to that gigaton scale, to get to that many gigaton scale that's required.
Yeah, I really like what you guys are doing in terms of the size of your systems. I think if you have heard of CDR, you probably know about Climeworks and companies like Carbon Engineering, where they're doing these very large systems. And you know, you and I have had a discussion about this, but this idea that your systems are smaller and the speed with which you can iterate, you want to talk about that a little bit more?
Yeah, sure. I mean, most people, when they look at technology, chemical engineers, you think, okay, if I scale up a process, it gets cheaper on a unit economic basis. Oil and gas plants, typical processing plants. Direct air capture is a little unique. We think the opposite is true, right? There are places in kind of scale of direct air capture processes where the economics get cheaper. But as you build bigger and bigger plants, that's not necessarily the case. So one of the things that we do is we look at high efficient, high exergy integrated system design. So it's one thing to pull CO2 out of the air, but so what, who cares? Nobody wants to buy, very few people want to buy CO2 that's a gas that just comes out of a machine. They want high grade liquid, low oxygen content, perhaps supercritical CO2 for injection, dry ice for supply chains, or they want CO2 as a product to make other things like fuels. So what we do is we think about how do we integrate these systems, And how do we find the most efficient fans, the most efficient ways of moving the air, of addressing these energy issues that are embodied in the system design, and integrate those to reduce the cost overall. So our view is we use modular scale DAC. So our machines are roughly 4.5 feet wide, 12 feet tall. They do about 100 metric tons per year of CO2 from the air. And we believe that a larger number of smaller machines is more cost effective than a smaller number of larger machines. But there's another reason why we do that. The other reason why we do that is the learning by doing curve. It's pretty well understood that every doubling of technology capacity shows a 10 to 30% reduction in cost. So by building smaller machines, putting these out into our customers' hands, we can drive our costs down rapidly. So we're not at this point entirely focused on sequestration or pumping CO2 into the ground. We think it's a little backwards to apply your highest cost, earliest, highest risk technology to a scale that's required for sequestration. But eventually, as we drive our costs down, we figure out the supply chain, we figure out scale up manufacturing, we'll get there.
Thanks, Matt.
So I think there's 2 points for me that come top of mind. One of them is I really like to think about how do you build a flywheel for growth? As Anne just said, we're at 6,000 metric tons captured a year. So like not exactly where we want to be. We want to be at 10 billion tons. That's really hard. So one of the things that we think about a lot at Lithos Carbon is what I like to call our Tesla model. I know that he's not the most popular right now, but I would argue that there was something very smart there, which is I would argue that instead of building an electric car, Elon Musk built a car that you want. It's really cool, wonky doors. Like I remember the first time I saw it and I was like, what is that thing on the street? It drives really fast. You want the car. It happens to be electric and you want the car and it will, because everyone wants it, it will solve climate change. And so likewise at Lithos, we're actually trying to build something where we do the carbon capture stuff. We measure that very precisely. That's absolutely critical. But actually, when we work with farmers who are our vehicle and our engine for capturing carbon, and also I come from a farming family background, we actually focus on building something that the farmers will want and love and need. So like the consumer software thing. So we are actually replacing an existing expensive input that they already use, agricultural limestone, which actually releases CO2. It's CaCO3. 40% of its weight comes out of your field as CO2. They all have to use this because fields are acidic and you need to deacidify your fields. We replace the limestone for every single farmer that we work with. And we actually do that for free because we use the carbon credits. And so that's actually what we do. A lot of our science is not actually just the carbon capture part, which is like half our tech stack. Half of our entire tech stack is like, how do we replace limestone for farmers reliably? And so that's actually the flywheel that we are trying to build. We're trying to build something that farmers want and love and need. And then through that, solve the climate crisis. So we improve crop yields. We are doing so much research on agronomic benefits for the fields. Again, we're not robots. We do need to eat. Agriculture is 25% of the world's emissions. Just like Matt was saying, you need to solve the problems that you need to solve. And so that is one of the ways that we think about scaling. Build something that farmers want, build an engine of growth that will work even if carbon credits didn't exist, because financing is a big problem, which I'm sure we're going to get to. That is how we tackle the climate crisis. The second thing, which is not a very fancy one, not very glamorous, is just I honestly think it takes a lot of grit. Like this is truly a moonshot. Human beings have not actually done this before. There is no playbook for change. So when we talk about building smaller modular things, we talk about like using farming and like replacing a weird dust with a different volcanic carbon trapping dust. Like there's no playbook for doing these things. And I come from a, consumer software background. There's a lot of playbooks in that. I think there truly isn't a playbook. So we need talent that is creative, talent that will roll up their sleeves and figure out something that nobody has ever done before, and think about things in new ways, because we need this industry to scale like something like 5,000 times in the next 7 years. That's faster than semiconductors and most things that human beings have done. That's going to be hard. So we really need to put our collective consciousness to work and think about creative ways of getting the job done.
Yeah, thanks. And I think you started touching on the credit and the carbon markets. I want to hear what Svenja has to say about that.
Yeah, I love system thinking and what we're trying to solve, the scale, the courage we need. It's a system thinking optimization problem. We are facing a lot of boundaries in there. One of them is time. The other one is finance. We touched on that. The other one is technological readiness that we are working on. And the other one is just the readiness of the market. Carbon markets are not a new thing. They've been around for a long time under the Kyoto Protocol. It was called the CDM, the Clean Development Mechanism, which profoundly helped to scale renewable energies back 25 years ago. So we are not doing this for the first time, using the carbon market as an enabler for technological innovation. But back then, we mainly dealt with solar, wind. It was not as fragmented from the technology side. Now we are dealing with, maybe none of you have heard before about enhanced weathering or direct air capture. And there's a set of other technologies out there that are being developed, but there's really no vehicle to bring them into the carbon market because the missing link is methodologies. If you're a project developer and you want to bring your project into the market, we have some wonderful colleagues here in the audience. There are registries and standards that come out with methodologies such like Puro Earth or Vera. We've all heard Vera in the media over the last couple of weeks, month, that help project developers and often co-develop methodologies with project developers to quantify the value of carbon credits that come out of those projects. Those methodology developments usually take time, and that's time we don't have. So thinking about how those projects are currently being financed, a lot of them are financed through something called forward purchase agreements. You have a company, a startup that comes out with a technology that's very promising. LCAs, life cycle assessments, techno-economic studies are being conducted. Project boundaries are defined. Finance is needed, but it's a lot of risk. It's risky capital. So one way to access the capital market is by forward selling your carbon credits. Where's the risk? Well, there's no methodology. A lot of those projects are self-verifying, self-certifying, and the critical piece to measure the success, remember the acronym from the beginning, MRV, it's called measurement, reporting, and verification, doesn't exist either. It's not to say that there are bad players in the market, but for me and as a capital allocator, it's really important to de-risk the capital I'm allocating, and that's through risk management, measuring projects, measuring the project success, and closely working with registries and technologies we are interested in to come forth with methodologies that bring the market together and don't further fragment it.
And can you guys talk a little bit about how you are addressing carbon credits or the measurement and verification part of it through technologies that you may be incorporating into your systems or into your practices?
Sure. Whoops. Sorry, I turned it off. It's a Friday. So MRV is actually half of our tech stack. Before we commercialize, before we start to actually like forward deploy and work on large commercial farms, we want to develop an MRV method that we believed had good precision, worked in certain areas that we were confident about. We're now, deploying over 8 states, so trying to figure out how this works in different kind of soils and stuff. But we think that's absolutely critical. I think that you actually should not be scaling a technology unless you do actually know how to be measuring it, because I think that the biggest, if we call this a moonshot, the biggest risk to our collective field of carbon capture and all of this fun stuff is that if there's not credibility in the field, kind of like all the Bloomberg articles that are coming out right now, if there's not credibility, we will blow up on the launch pad and we will have like 5 years to capture carbon at 6,000 tons of carbon a year. We will not get very far. That's like scooping a cup of water out of the ocean. So we really do need trust and credibility in the field. I think that comes absolutely first. So we've developed a technology, I won't get into the details, where we're able to measure with isotope tracers and an expensive mass spectrometer, which is like a $500,000 machine. It's actually a technique that comes from biotech. So we like to take lessons from other places. That's actually how we measure the carbon that we are capturing in the field, the permanent carbon capture we do. So we have worked with different method developers. One of them is here, Puro. So we helped work on an early stage of a methodology that is live today. We're very excited about that. And we are also looking to just figure out, how do we push the field forward? How do we increase the rate of learning, as Matt just said? Because an unfortunate thing about carbon capture and just generally science, like, crops do not grow the same everywhere. Every single solution you come up with is going to be differently effective in different areas. So how do we increase the rate of learning? How do we, in parallel, deploy scale carbon capture and also be very honest and real and accountable with ourselves about the gaps in knowledge and also work collectively as a field to close those gaps. I actually think, hot take for myself, is that I think that a lot of the research and academic work that is done today actually shouldn't just be proprietary, probably shouldn't just be patented, because, you know, we don't have time to wait for just one company to try scale carbon capture or, you know, a solution to climate change. I actually think that some amount of this might be a little bit of a different playbook from like software as a service, but some amount of this should actually be open, not proprietary. So that's something we also think about a lot at Lithos. Like, how do we contribute to the greater good here? How do we make our data accessible and open source? You know, how do we make things peer reviewed? I think that the rate of learning needs to increase like exponentially. Our deployments obviously need to exponentially increase. We can't just have fun research. We also need to deploy and learn. And I think it's challenging because human beings have not moved quite as fast as we need it to happen. So I think it's an incredibly exciting space to be in for those of you who are climate conscious and thinking about changing careers.
I take maybe a little bit of a more negative approach than most on carbon credits, but that's because our view is that scaling the critical factor for scaling this kind of technology is there's two sides of the coin. One is technology readiness. How reliable is it? How sure are we that we're doing what we say we're doing? And I'll talk about that in a second. But the other side of the coin is project finance, right? We need to get the bank markets, the project finance markets, the infrastructural funds really fundamentally comfortable, not just with the technology, but with the creditworthiness of the offtake of the technology. And the carbon credit market, in our view right now, is not something that we see big banks and financial institutions are going to come and say, oh yeah, that makes sense. We're going to take the credit risk of 10 years on a VCM credit for this thing, and we're going to give you all the money you need to build this plant to do that. We'll get there eventually. We're not there today. But what is it going to be required to get there? It really does come back to MRV, and direct air capture is really unique as regards to MRV. You know, one side of the coin, it seems pretty straightforward. We can pull CO2 out of the air and we can measure it. We can measure it with all kinds of different things. We started measuring it by putting it in a garbage bag and putting it on a scale. And we're like, oh, what are we going? You know, how are we going to measure this? Well, weigh it. Okay, that makes sense. But you can't do that at a large scale, right? So now we're integrating processes and systems and processes to do that. But with direct air capture, you know, the problematic part of it is that the carbon credit mechanism or the methodology to sell these credits is not just dependent on the technology approach that pulls CO2 out of the air, generates the carbon in the first place, but what are you doing with the carbon? It's very different if we're pumping it into the ground for sequestration or concrete blocks or putting it in a Coca-Cola. So those methodologies are required. Some are permanent, some are impermanent. We talk about planned release versus you know, permanently storing the CO2 in rock or underground. And these methodologies are required, in our view, in order for the VCM or the carbon credit market, the offtake market, to be mature enough to enable the kinds of financing that's required to scale.
Yeah, I appreciate that. I was just about to ask about carbon credits, and especially because a lot of people now are thinking about how can they come up with strategies to help themselves be more carbon neutral. And obviously, a lot of people have been looking at carbon credits, but one of the things that I think that there's a hope is that some of the carbon credits can help fund and help scale some of these new technologies. But I think there is a lot there that we still have to think about, and that still has to grow. I'm curious, you know, we've kind of talked about immediately what we're looking at in terms of scaling. What do you see as the next, you know, the next almost frontier for getting us to scale even bigger? Like, is that more on the technology side, either specifically about what you guys are looking at in terms of your company, or is it on the finance, or is it on the policy side? That, you know, those three things really play together, and curious about what your guys' take is on that.
I can put a quick answer out there. I think that the biggest thing that's required, the technology will get there, but I think it's on the project, it's on the policy and the finance side. And if carbon removal, if engineered carbon removal doesn't become the world's largest market in the next 10 or 20 years, we should just all move to the mountains and buy guns. So what does it take to get the infrastructure investors and the policy folks to really understand that this isn't just something that we need, but it's a huge opportunity for economic growth, for job creation, and it's the infrastructure of the future to solve the problem. We have the technology. It may be high cost right now. We'll get those costs down over time. We're highly confident in that. But I think it really does take people to recognize and realize that it's not just a crisis, the amount of CO2 in the air, it's an opportunity. And it's an opportunity to solve the problem and generate jobs and economic growth moving forward. And I think that's the inflection point that we need people to wake up to in order to really get this going.
The great news is I had the same answer. Policy and finance are the two things I would double down on. And there's massive gaps in each. To dive into the finance side. So I actually share Matt's view in some perspective. When I started Lithos, I wasn't really thinking that much about the carbon credits. I called up fertilizer company founders and I was like, how do you start a fertilizer company? Because I was saying the first part of Flywheel is like, if you can build something farmers want and love and need and it works and it happens to capture carbon, that seems good for the climate crisis, right? So I learned about that. And I think that's actually very important. Like it is actually a very good idea to build a climate tech company that is buffered against the winds of change and the volatility in the climate markets carbon markets, not climate markets, and the carbon markets, because policy is not in place yet. I think if policy had kicked in to say that there's all these different forms of sequestration, how are we using the CO2? What's the permanence of CO2? If that happened 10 years ago, then I would have done a different thing when we founded Lithos, but instead I was calling fertilizer company founders. So I think that there's a massive gap in finance though. We are working on building a solution that I think works. Hopefully, even if VCMs voluntary carbon markets don't exist. At the same time, today, I can say that it's very helpful for companies like ourselves and a lot of other companies out there. When you can claim a carbon credit, it funds your research. There's so much research to be done. There's so much deployment to be done. And every single early stage technology is expensive. That's just like a fact of life. We cannot have cheap Costco hot dogs if they were not expensive to make, as a small mom and pop store, right? So we are one of the frontier climate companies. We are so excited to be working with a Frontier, which is an advanced market commitments to fund early stage and honestly a little bit more expensive carbon solutions. And I think that is just enormous for companies who are trying to figure out how do you get your first revenue? How do you prove to investors, right? Typical VCs, that there is a market for what we're doing when the policy hasn't happened yet. So I think if we lived in a different world and the policy all existed, like I would be saying a different answer. But I think the policy side is incredibly important as well. You need regulation around this stuff. It would be very cool if there was, a cap and trade market for all of this. I think that we need better definitions. Like I've been talking to a bunch of buyers and they use different definitions of issuance and contracting and what does it mean to retire? I'm like, whoa, like y'all are big mega cap companies and you have totally different definitions and there is no, established form for that. So I think there are massive gaps in both. I'm so excited about all the conversations I've heard this week. Oh, thank you. All the conversations I've heard about this week where policymakers, where financiers are stepping in and trying to close those gaps. And I think we need to have those hard conversations because it's a hard problem. Great.
Yeah, I agree with both. It's finance and policy. That's really the crux of it. And right now it's a chicken and an egg problem. And thinking about the VCM, I think we got used to the acronym by now, as a driving force of this innovation, it's not going to work. We are talking about a market that has less than $2 billion. We need trillions. We need trillions of dollars to succeed in this. In comparison, the compliance market, we're talking about $800 billion annually. So it's a big brother. We have another market, which is the global carbon market under the Paris Agreement, which is currently rolling out. And it's curious to see what is going to happen under that carbon market of the UN with carbon removals, how carbon removals are going to be defined. And we've been talking a lot about technology-based carbon removals here. The other side of the coin is nature-based carbon removals. We have those too, mangroves, reforestation, and so on and so forth. And we need everything everywhere all at once. It's an incredibly complex equation, and we just need to be smart about where we allocate capital. And it's going to be a learning curve. Not every solution is going to be the right fit for for a country, for a climate, a desert will require different solutions than rainforest, and so on and so forth. But the message here is really that it's a lot of education. And even though we think, well, the UN knows, the UN figures it out, it's so new, it's so dynamic and agile, the space, that it's a lot of education, fast education, to make policymakers understand that we need support from regulators, from the UN mechanisms, and we also need smarter ways to structure these projects, such as blended finance. We are seeing a lot of initiatives here in the US, especially the IRA, 45Q tax credits for sequestering carbon in the ground, where you, as a project developer, can claim $180 per ton for each ton sequestered. That's a huge help because it de-risks the project. But we need more of that. We need smarter vehicles that can structure those deals. We've done it all under renewable energies, but back then the incentive from regulators wasn't that strong. So we have more catalysts. We know Breakthrough Energy Venture Catalyst, a lot of regulators, and hopefully also more multilateral climate funds, such as the Green Climate Fund, that understands the importance of carbon removals, not just in the global north as an R&D trial, but also deployment into the global south, and understanding co-benefits of those technologies in addition to carbon removal capacity.
Great, thank you. So we're gonna wrap up soon. I'm gonna have a little bit of time for Q&A. So start thinking about your questions for the panelists. But before we wrap up, all of Climate Week for me has been about making really great connections and finding out more about what other people are doing out in this space. So my last question for our panelists is just to ask them, who would you like to highlight, or what technology might they be working on that you think is worth giving them a shout out, or something for people to look at, or if they're here, call them out as another person for people to make a connection with. Matt, you want to start?
Yeah, sure, I'll get started. We just announced a project with a company that we're working with that is called Carbon Built, and they're injecting CO2 that we're pulling out of there into concrete blocks. I think that's pretty awesome. It makes the concrete blocks stronger, lighter, less concrete, has massive carbon benefits. There's a lot of companies like this that are putting CO2 into the built environment. And I think this is a sector that has a huge opportunity. The built environment could represent something like 50% of the solution set over time.
I would like to give kudos to two of my colleagues that are here. You can go back them after the panel, Daniel and Sarah Beth from Puro Earth and NASDAQ. And I think it's a very beautiful partnership, because we, on one side, we see NASDAQ, and then a small startup that was started in Finland coming together and really trying to figure it out and going through thick and thin together. Because how do these pieces fit together? How does innovation fit into a capital market context? And really pushing for it, driving the narrative, driving innovation, and I think also giving courage to other larger players in the market to see a real potential here, not just from a climate change perspective, but also from an innovation and from an investment perspective. So thanks to you guys.
I met so many really cool technologies this week. It's very hard to say. One technology that we're very excited about, it's afforestation with a twist on it, because there's a lot of conversations about like, where should you actually afforest? There's a company called Momback. It's also likewise quite young. They're actually buying land in what used to be the Amazon. So basically the Amazon rainforest was bought up by a bunch of like pasture and rangeland growers and, you know, torn down. And now that land is no longer fertile and not very good for pasture. And they are actually buying it back and turning it back into the rainforest. And I think it's like a lovely sort of picture and a really exciting thing to think about, because we really should have a forest there. So that's something we're excited about.
Yeah, thank you. And I'm going to take a moment to also give a shout out to Dylan Garrett. He's one of my colleagues at Synapse, and he's a real inspiration to me. What we have to do, the scale at which we have to develop requires us all to collaborate and be inspired by people doing work in this space. And he started a podcast called Hardware to Save a Planet, and it's inspired me and really opened up my eyes to a lot of people, a lot of great people doing work here. So if you're interested in learning about more people doing this kind of work, listen to his podcast. If you're doing something cool, get on his podcast, because it's starting to reach a lot of people and it's really starting to build a lot of momentum. So it's a little bit of a plug, but I do think it's personally really inspiring and very cool for me. All right, let's open this up to some questions. Oh, great. I see a lot of people. Yeah, go ahead. Let's start over here.
Thanks, all of you. That was really interesting to hear. As somebody who's kind of coming from outside the CDR space for sure, and outside the carbon market space, I think there was a large part of the conversation that focused on the credibility of the carbon market space. I guess BCMs in particular, but also the compliance, like all the carbon markets. And it seems you touched on how a lot of times the folks that are seeking to receive funding through these credits are the ones that are doing the measurement. And it seems like there's kind of a large need for some sort of third-party measurements, third-party, like we have ratings agencies for credit risk. And I guess that kind of touches on how the lack of credibility actually affects whether financing can occur for these projects. Why do you think that doesn't exist yet? Is it just we haven't had time to create that, or are there barriers out there that somebody who isn't as well informed about the space is not seeing?
I can answer that quickly. I would say that was a great example of hitting the nail on the head with a great question. That's the critical element here, right? I mean, in our view, there should be third-party companies that provide independent services. There should be joint industry partnerships with independent organizations that can provide the verification. That's what's going to be required to get the market, a trust in the market large enough so that folks believe what's going on, and that that companies can't sweep under the rug some of the critical things that are going to happen. Those kinds of things have happened in the past. I'm sure they'll happen moving forward. That undermines trust in the market, and that makes it more difficult to move this forward. But I think that's the next big step. And I think the reason why it really hasn't happened is because, in the engineered CDR space, the technology is so new. I mean, we're just at the precipice of this, and there's some folks really thinking smartly about this. And, I think companies like ours, we want to work with them and integrate their solutions. And it shouldn't be something that we do. It should be something that somebody else does, that somebody else can point to as proof of record.
I just want to plus one that I very much agree. There are some smaller third parties in the space that are just beginning, and I think we need more. There's actually a very cool company that I think it just very recently launched. It's called Icarus, and they're actually trying to do the chain of custody and all the information, all the DMRV and all of this for a bunch of different CDR companies, including DAC, which I think is actually absolutely needed. I think the data is actually quite important. Like, we're capturing carbon, and I'm not going to give you the carbon. You don't want the carbon, right? Like, we're burying it, or we're doing something like transforming into bicarbonate. And that's actually pretty hard for like human beings to really wrap our minds around. It's like data, right? And so how do we make that data third party? How do we put it somewhere that someone else manages, not the companies themselves, and make that very trustworthy? I think that's actually a massive gap in the market. I think Icarus is actually very cool, and they're just launching, and they're working on solving that.
Thank you. Michelle from Clever Carbon and Women in Climate. Thank you, panelists. There's a lot of awareness and focus around land-based CDR. Our planet is 30% land and 70% oceans, and our phytoplankton absorb more, if not, more, CO2 than our plants and our trees. And so I want to, ask the panelists, what type of ocean CDR is on your radar?
I love the ocean. I'm a scuba diver. So I saw a funny Twitter exchange the other day. They were arguing about whether enhanced weathering was ocean CDR or land, and we were busy, so we didn't chip in. But there are folks that actually argue that enhanced weathering is ocean CDR, because that's fundamentally where the bicarbonates that we're creating are stored. If they don't go there, it might not be stored. And so I completely agree with you. When we are creating bicarbonates, it goes into like potentially the shells of these phytoplankton. And I think that's actually an incredibly important thing. For folks who don't know, like I studied ocean biogeochemistry. And actually for folks who don't know, the oceans store about 50 times, it depends on climatary conditions, but about 50 times more carbon dioxide than the atmosphere. Is like, you should like look up those cool Wikipedia syncs, like where is the carbon dioxide in the biosphere and everything. So I think oceans are incredibly powerful. I think actually the gap is the MRV thing. So there are a number of different OAE, ocean alkalinity enhancement companies. Ebb Carbon is one of them. I think they've recently announced a raise a couple of days ago, but the MRV is quite hard, and also building the systems is just a challenging thing to do. So I think we should think more about the oceans. I think there's a lot of grants mechanisms that are trying to fund research into the oceans, which I'm really excited about. And yeah, +1 on that. We should think about it more. There are some fledgling companies looking at it today, and some people argue we are oceans. Actually, I'm not really sure which one we are.
Great, thanks.
Mary, how are you sourcing your bicarbonate without incurring a carbon logistics penalty?
Yeah, so we use basalt and then we create the bicarbonate. So I don't source the bicarbonate. So we use basalt, which is a volcanic rock. It's the fourth most common mineral in the world today. So there's plenty of it. It's not like a hard thing to find. We actually don't crush or mine our rock. We only used waste byproducts, and we've still never crushed or mined our rock. So actually when we started the company, we called a bunch of quarries, because if you Google it, you're not going to find it. We called a bunch of quarries, tried to look for this rock, got in touch with them, got in touch with their quarry control managers, or QC managers, sorry, quality control managers, and found these massive million-ton stockpiles that have been sitting there for sometimes decades and not capturing carbon that quickly. I can talk about the kinetics of that as well. So this is actually a waste byproduct. It has no commercial or saleable value. It's something that comes out when you're crushing down basalt for other basalt specialty products. And that's what we use today. We do have to move that. It's a very heavy rock. So there are some emissions involved in that. We subtract that from the carbon that we're capturing. We do a full LCA before we deliver a credit to a buyer. One of the things, if there's anyone out here who works in railroads, would love to chat with you. We're working on trying to get the railroads to work with us, because that's more efficient, cheaper. The emissions are better than trucks. Railroads don't really want to work with very small young companies, but I've been working on it. So that would actually help with the emissions as well. Great question.
All right, right here. And you can pass it back after you're done.
Hi, thank you all for your panel and wisdom. You talked about grit being one of the things that was important, but what are some of the other skill sets you see a gap in the market for progressing CO2 removal forward?
I can talk about it. I think a really interesting frontier and thought frontier, and also quantification frontier in the carbon removal space, especially on the engineered, on the tech-based side, is co-benefits. On the nature-based side, some would probably agree, others would disagree. Co-benefits of projects are easier to quantify and have been just more thought of. The UN has been working on this for 15 years. And we see as part of projects, and I can talk about nature-based removal projects such as reforestation, we have other environmental co-benefits, educational co-benefits, economic co-benefits, health co-benefits. And that really helps to frame carbon removal projects as a larger sustainability projects that has other impacts. That hasn't been really the case on the technology-based side. So this sort of additional benefit of a project, which also often reflects in the price, that the value, the social value of a project, is, in my opinion, currently not very clearly defined, and also obviously varies from project to project, from region to region. But it's going to help to pull in different capital other than just the pure carbon and tech capital, and embed it in a larger SDG framework. So I think that's one of the biggest frontiers.
I have one more quick one. I think that a skill set that I would love to see more of, and I think would really accelerate our field is, and we can all do it, is I would love if there's more scientific literacy. And I think everyone in this room is definitely scientific literate, but like the technology development, the new ideas are coming up, they're in papers, they're not in blog posts, unfortunately, right? And I actually am one of those weird folks who likes to just read papers because they're interesting and fun. And I think that folks should be more eager to do that. I actually think it can be fun. There's a lot of really interesting tidbits. They are fodder for great conversation and critical arguments. And it would be awesome if, like, random business person I interview loves to just read technical papers. I think they would actually learn a lot and it would just help us all come up with better ideas. So that's a random kind of pet peeve of mine. And I think something we actually all can do.
And one of the things I've talked to a lot of companies as well, asking them, what kind of capabilities you need? And I was thinking something more along the lines of chemistry or, different science, deep science backgrounds. And one of the things, or two of the things that keep coming up in those conversations are really around being able to manage large scale projects, which I like that because it says you don't have, there's a lot of that out there. There's a lot of that that's happening now. And if you are organized and have that way of thinking, that systems way of thinking, you can be extremely helpful in this development. And then the other one is really around manufacturing. We're talking about scaling, but how do you take some of these new technologies that people are creating and think about ways to manufacture them? So Matt and I have talked about, how do you use what we're doing in the automotive sector to think about how do you create some of these industrial systems and products? And it's that kind of thinking that is going to really help, which is not very specific to some deep scientific background. So I think it's a place where all of us can really help out.
Hi, thanks for a very interesting discussion. I wanted to ask a bit of a controversial question. So what would happen, let's say 2-3 years from now, some country decides to put thousands of tons of SO2 in the stratosphere. And we observe that the Earth does cool down. And they do that for several years and it just stays this way. We measure the side effects. We know how much the damage it does to the ozone layer, acid rain, everything. And everything is bad, but kind of under control. What would happen to carbon removal businesses? Would they still be enough demand? Do you see a demand lasting if we solve the warming problem differently?
It's an interesting question. What would happen? I hope we don't have to find out. I think that carbon removal, you can view it through two lenses. Remove carbon because we want to get it out of the atmosphere, period, right? So that need might go away. Or remove carbon from the atmosphere because we can make all the carbon-based products that runs the global economy from the air instead of from the ground. That still will need to happen. So my view is, the solution set or the what happens ultimately to what we do with that carbon will be, it may change. But for example, agriculture, there's all these co-benefits that still need to happen. Economics may not, in that case, be driven by the atmospheric carbon reduction or permanence, but those co-benefits need to be monetizable and well understood. I think even in that case, all these technologies are still the technologies of the future.
Yeah. So along those lines, I also think, maybe someone does that, which I also hope doesn't happen. But we are still going to have a society. We're still going to need to do certain things like fly around and grow crops and, all of that is still not net zero. So I think that there's still a market for that. That goes back to my question when we started Lithos, which was like, how do you start a fertilizer company? I will also say, just like as a scientist, that generally there's a lot of second order effects in nature that often happen when you do something. And no matter how much we model them, it's hard to know what they are until they happen. So I would just, urge caution in general with second order effects.
Great. Well, we're just about out of time. I know I see a lot of people who still have questions. It's very exciting. First of all, I'd like to thank our panelists. This has been a really great discussion. I think this is just the tip of the iceberg for information around carbon dioxide removal. I encourage everyone here to take a moment to say hi to the panelists. If you still have questions, please come up and see them. I also encourage everyone to reach out to us on LinkedIn. I feel like I do a lot of these talks, but then everyone seems very interested and not very many people connect with me on LinkedIn. And I think, like I said before, this is all about making the connections and collaborating together. And so the more we can do that, the better off we'll be. And hopefully the faster we'll get to the solutions that we need to get to in order to affect climate change. And then finally, I'd like to thank Capgemini AIE Space for hosting us. This is a really wonderful place. I hope everyone enjoys the rest of their time here. We have lots of food and drink left, and lots of people left here to have great conversations with. So thank you very much. Hope this is a great end of your week, and have a great Earth Day celebration tomorrow. Thank you, everyone.